So my name is Carly, and today I want to talk to you about OpenTelemetry, but in a different way. I want to talk about the state of it in the front end ecosystem, specifically talking about web apps and some of the cool stuff you can do with it, even though it's a little bit experimental at the moment. So, firstly, to introduce myself properly, my name is Carly Richmond. I actually lead the developer advocacy team in DevRel at Elastic. Before that, I worked in a large investment bank for 10 years, most notably as a software engineer, and experienced a lot of outages and a lot of problems, which is part of the reason why I like talking about monitoring in this topic. We should have time at the end for Q&A, but if you think of something afterwards, you can catch me in the hall, or alternatively, you can find me in whichever socials by using the QR code, because I feel like I'm collecting them like Pokemon at the moment. So just find me at the right place that works for you if you want to chat and you've got any questions. So we're talking about the user side of monitoring. We want to monitor what a user does, and not in a creepy way. I'm meaning more in a useful way in terms of identifying common errors that might have triggered bottlenecks or problems within a more expansive ecosystem. And that was something that I really, as a front-end engineer, needed to know. And when we think about the user experience in monitoring, we think about two things. We think about real user monitoring, identifying those performance bottlenecks and other aspects. But then there's also this notion of digital experience monitoring, which is, are they having a good experience? Are they having a good experience on particular browsers? Is someone crazy enough to still be using Internet Explorer in 2025 and therefore half of the site doesn't work? All of these things that sadly might still be happening. So I said I was a front-end engineer before. I was the first port of call. So whenever an issue got triaged and escalated, all a user knows and understands is that, oh, a number's wrong or a button doesn't work. So quite often it came to me first because it might be the UI. Now, sometimes it was. I'm not perfect. But sometimes it wasn't, because there was a myriad of microservices and other stuff in the background that could cause an error. And half the time it was my job to figure out where the bottleneck was or the issue was to start with. But the problem is, with all the fancy monitoring that we've been doing, using technologies such as OpenTelemetry or anything else that you're using, we're instrumenting back-end services. We're getting pretty good at that. But how many of you are actually instrumenting your front end? So nobody's here, either because you're not dealing with the front end, which might be a possibility. But for some of you, clearly it's just, no, we've not got anything on it at all. And that's terrifying because, believe it or not, it's not always the back-end service that goes wrong. So some may be still using real user monitoring agents. Does anyone use a RUM agent? Okay, so there's a few people that are using RUM agents and doing something. That's a good start. One of the big problems with RUM agents, though, is that they tend to be very vendor locked in. There is the Boomerang JS approach, which is intended to be a bit more open. But the fact of the matter is, RUM agents have a very strict contract coupled to that particular ecosystem and that vendor, and therefore you're stuck because you can make it very difficult to actually move your full set of monitoring capabilities. Now, one of the main ethoses of OpenTelemetry, I'm not going to explain what OpenTelemetry is because I'm assuming this is base knowledge, is the notion of we were meant to have front to back telemetry at all layers. So it didn't matter whether you were talking about the network layer or the front end browser. The whole point was we should be able to use open vendor neutral SDKs and technologies in order to do that. And we've covered, everyone's seen various different demonstrations and different technologies of how we can do either automatic or manual instrumentation of OpenTelemetry within backend services in Go or Java or whatever. But the thing is, the front end stuff's a bit behind the curve just because of this big warning here that says, warning, client instrumentation for the browser is experimental and mostly unspecified. So the stuff I'm going to show you is experimental. It might break. But the fact of the matter is there are still some things that we can do in order to kind of get to understand how we can instrument in the same way on the front end with some particular tweaks. And these are the examples we're going to go through today. Now, I'm not saying it's all doom and gloom. So for those who are interested in this topic more generally, the instrumentation is covered by a specific special interest group within the CNCF ecosystem known as client instrumentation. And this is the state of their board at the moment. So they're working on some cool stuff, such as a Core Web Vitals plugin. Are we all familiar with what Core Web Vitals are? Cool. So we will probably gloss through that. We've all learned from last time, so that's cool. And then other things such as page view, event instrumentation, and other various things. But like any community-driven project, of course, if you're interested, join the SIG, help out. I'm sure they'd be more than happy to take some help. But I'm going to show you how you can use things just now using my little demo app. So this is a very simple record store application that you can look through records and as an event and news page. Doesn't do anything too exciting, but it allows us to showcase the key instrumentation for a front end and the things that are similar and the same as what we do with backend services versus what. This is going to be our kind of monitoring architecture. So I have here, I'm using the JavaScript SDK. Now I am using it with TypeScript, so I'm importing the types as well. I'm passing the spans through a proxy, and we'll talk about why that is in a minute. I've got some additional processing going into a collector. That's just more for reference that it's there. And then it's going into an open telemetry protocol compliant backend, which in this case is going to be Elastic. Is everybody with me? Sweet. Okay. So the reason we need the proxy is this. Cross-origin request. Has anyone ever had this reaction when they see that error? Yeah, we've all been there. It's horrible. I had a great one with Kaggle a few months ago. If anyone wants to hear the story about how I got into such a mess with TensorFlow Hub, come and find me afterwards. Anyway, that's not the point, right? We need to make sure these spans are passing through, and for that reason, we need to adhere to the appropriate cross-origin request policy stuff. And that means, therefore, that we need to make sure that our proxy is adding the appropriate cross-origin request headers. And you'll need to apply this for each of the collector endpoints that we're talking about. So traces, metrics, and logs, if you're collecting all of these, you're going to need to make sure that you've got the appropriate headers, credentials, and origin settings. Otherwise, you're going to see nothing. Now, let's get into some code, shall we? So, like any open telemetry specification, we need a resource, right? And our resource here is going to be the front end. And what we need to do is create a new one. But there's one thing that's a bit different from maybe some of the resources you created before, and it's this browser detector right at the top. We want to detect the browser information. Remember, we wanted to find out if anyone was still using Internet Explorer in 2025? The browser detector picks up these important browser information, things such as which browser it is, whether it's mobile or desktop, because I've had the situation where an error is very specific to a browser, and you want to have that telemetry information passing through. So to make sure, we add the browser detector so that those are being passed on to the attributes. That means, therefore, when we create our resource from attributes, we need to merge it together with the browser detector stuff. So that's the only thing that might be a little bit different. Obviously, it needs a service name. Like, you need to name your resources, otherwise you're going to get random traces and not know where they're coming from. You need to also specify, I like to specify version and deployment, just because I'm the person that was like, was that issue in UAT last week before we deployed? I really can't remember. So I'd like to be able to sometimes compare, and those attributes I've found to be useful in the past for that. So we know about our different types of signals, right, for OpenTelemetry. So these are going to be the 3 types of signals we're going to capture. And if we start with logs, when we talk about servers, it's really obvious. We tend to spit everything out into a file somewhere on the file system, and then we send it and ship it off to an elk stack or something else, and we're all happy and we can see our logs. In the front end, most of us don't bother. We rely on DevTools console. And I'll admit I've done this as well. But the problem is, if your user's not accessible, how are you going to see what went wrong? How are you going to see your errors? You're not. I was lucky. I worked in a bank. My user was 2 floors down, so I could run down the stairs in a panic, which has indeed happened. You can't do this if your user's on the other side of the world. So we need to ship these in. So what we need to do, which will start to look familiar to people, is we need to specify an exporter. Because I'm sending to an OpenTelemetry compatible backend like Elastic, we use the OpenTelemetry protocol-based one. And we send it in through the proxy because we want all the headers and cross-origin settings to be added on, and then it will go through in, as we said, through the architecture. We then need to create our provider, so we specify the resource, and then the processor is going to use that export, and I've put a batch log processor because I don't want to get random errors because it ends up saying, oh, you're sending me too much. We then set the provider as the local provider, for the whole of the project. And from there, rather than console.log, so we can actually see stuff, what you do is get a hold of the logger and then use emit. And that means that you'll actually end up sending your logs from the front end directly into the back end so that you can actually search and see things and get the associated metadata information as well. Now, the next thing is metrics. So we all know what metrics are, right? I hope so. So these are quantifiable measures. Things that we can use to trend to maybe start to look and see if there's a particular problem or issue that might give us a hint that something is under strain. And when we think about backend services, it does depend partially on language, because of course, if it was a Java application, I'd want to know about the garbage collection and all those other aspects. But for a JavaScript server, CPU and memory, they're all absolutely fine. But for front end, we might think about some things like maybe particular error counts. We might talk about clicks of a user on a particular feature if we want to think more about the DEI viewpoint and seeing if a feature is indeed being used, which I have needed to do before to see if I could switch things off. But there are actually a standard set of measures, which are core web vitals, that we can use as a rough indication against the live traffic to see if we've got a well-performing site and if it's adhering to any particular bad practices that we can rectify around poor loading, poor responsiveness, etc. Most of us had put our hands up saying we knew what core web vitals were, but for those that looked at me blankly and go, Carly, what are you talking about? They're basically a set of measures initially proposed by Google in May of 2020 that are intended as a bit of a baseline standard for user experience. So if you're in the good, generally like any other red, amber, green status, which anyone who used to work in a bank and solves the spreadsheets is probably, yep, I remember those. You will see this notion of good needs improvement and poor. Okay. So you don't want poor. I think that's obvious. You want them to try and be in the good range where you can. So of our three measures, the things that we're measuring is the loading experience, i.e. is it loading in a reasonable amount of time? And that's where we use largest contentful paint. You've then got interaction to next paint as the main interactivity measure. This is different. IMP actually became a core web vital in May of 2024, so last year. So before, we would have had this talk about first input delay and FID. Now, the limitation with FID is while it gives you an indication of interactivity, it's the first user action on the page that it measures for, i.e. the first click or text entry or thing they've done on the page. If you're building a multi-stage workflow in the front end that a user is going to use, that's a little bit useless if stage 4 is taking 20 minutes and stage 1 is taking 2 seconds. It's going to throw everything off, isn't it? So interaction to next paint tends to be the one we talk about because it basically looks at all the events in the life cycle of the page. And then our third one, that's cumulative layout shift. And that's basically how stable the page is. Are things moving about a lot? Because that can be an indication of error. You're going to end up cancelling instead of confirming, or indeed that it's a negative experience. So does anyone read recipes online and like to try recipes like I do? There's a few of us. How many of you get annoyed by those ad pop-ups popping up in the middle? The CLS on those sites, this is surprisingly high. I think you can guess why. But there's other things too that we might want to measure. So the load of a page is important. There are techniques we can use in web apps, such as server-side rendering, to perhaps optimize and give a better experience there. But we need to look at the loading of all the other assets like images and things too. So time to first byte it's not a core web vital by definition, is another vital of interest where we can basically measure the time between the request going out and the first byte of the response coming back, which is pretty straightforward. We said there was no plugin yet, but you can do something yourself with not that much effort, or you can steal my code as well, which we'll show the repo at the end, and I don't mind. So this is my code. So what you'll see is that I've extended the instrumentation base. So see all the instrumentation in OpenTelemetry within JavaScript? This is what they're using, okay? This sets out the base contract of what you need to add in order for your instrumentation to be used and able to be registered. Now, if we scooch down a bit, I've basically created a utility to create my initial meter. So first I need to create a reader, which is going to read my measures. And as you can see here, again, it's OpenTelemetry protocol, and I'm specifying the proxy URL so that it will send everything through. I've set an export interval in of 10,000 milliseconds, which is 10 seconds. That's just because it's a demo and I'm impatient. The default is 60 seconds, which probably seems reasonable, but of course, given that this is a periodic exporter, it will export basically every 60 seconds as per the default. And then we create our new provider, again for meter. So you're starting to see this notion of exporters and providers, same patterns as we're used to, specifying the resource and then the reader which we've just specified. Then if we scooch up into the constructor, you'll see that I'm utilizing that same utility and setting it as the global provider. So it's the same pattern. The difference is the fact that we're talking about metrics. And then the other thing that's different is this notion of creating our instruments. So these are the things that we're going to actually measure. And what you'll see is I've got for each of the vitals that I've just talked about, I'm creating an observable gauge. So I'm just interested in what the values are. So an observable gauge will do what I need it to do. And I've specified the appropriate attributes of interest as well. Now, you're probably wondering, well, that's how you define everything. How do you actually use the thing? So what we need to do next is when the instrumentation is enabled and set up via the enable call in the contract, what we're going to do is basically add a callback function to send the metric. Okay, so send the metric my own utility. And I'm reporting all changes. So by default, with the Core Web Vitals library, it's only going to send you the first value. So if you want everything to get the trending, which is what I want here, report all changes as your friend. And you have to do this for, as you can see, each vital. We need to basically trigger the appropriate callback for that event. And then, as you can see, send metric is doing the same thing for every single one. So all I'm doing is I do get the current time. I get a hold of the attributes from the metric, such as the navigation type, the name, the value, and I have added in entries, which just gives me the JSON, but that's probably optional, to be perfectly honest. And then we call result.observe, and that will basically trigger those metrics being sent to the backend. So when we get the metrics, one of the things that's a bit sticky is the fact that if you're using a RUM agent today, you're probably used to an all singing, all dancing, shiny dashboard that all the data is automatically going in. And depending on your vendor, in fact, I'm not aware of any that are doing it at the moment, they're not actually compatible with the data that's coming from the open telemetry instrumentation that we've just done. But surely we've all created dashboards before. It's not that much of a heavy lift. So you'll be able to see things such as the trending over time, be able to see the state, and indeed you'll get this notion of poor experience versus good. Now this differs compared to traditional tools where we capture Core Web Vitals such as Google Lighthouse because it's based on the live traffic. It's not synthetically generated. So it actually gives you a real insight and a real-time insight as to what's going on and whether the experience is reasonable or if it's significantly slowed. Everybody with me so far? I see nods. Nods are good. Now, the last thing is traces. We all know what traces are. The pathway of execution through our application. So this is a really simple GET request coming out from my website, and it's in fact going back to a Java service to get a hold of the featured records and returning those. And we can see basically the pathway of execution through the connectivity between those two components, and we can also see how long each of these respective spans is taking. Pretty simple. Now, the bit that changes and gets a bit different. We're still using an exporter, still using OpenTelemetry protocol, still sending things through the proxy URL, the traces endpoint specifically. The web trace provider here is obviously a provider of traces, specifying the same resource, and then again, batch span processor, so it's sending things in batches. If you use the auto one, which just sends automatically, you might flood things, get weird errors. So batching is definitely what I would recommend. And I've set not just the exporter for the trace one up here, you can also add in multiple. So I've added in a console one just because. So this might be something you might do for a debug case. And then obviously for a production app, you would just send it all directly. And the same thing would apply to logs as well. Now, the bit that gets different is we need to register with propagators and a context manager. Does anyone think they know why? It's because traces have baggage, just like we do as humans. Now, context refers to basically I always get this the wrong way around, but we're going to try. Context refers to basically those attributes that are added on that can help us with the correlation piece. So active span ID. And we need to be able to make sure that's available in order to correlate with that backend service like we were talking about. But a lot of front-end frameworks use this funky thing called Zone.js. Is everyone familiar with Zone.js? No. So Zone.js basically is what's doing the background context switching stuff in the browser. That's what it is in simple terms. So in order to make sure that these spans and contexts are propagating across those async switches, we need to use the Zone Context Manager. And then the propagators, obviously I've got two, which is why there's a composite propagator in there. We're passing in baggage, which are these user-defined values that you might want to add onto a span. So things like maybe client ID or session ID or something like that. And then the trace context propagator is the HTTP headers. And these both adhere to the W3C respective standards of the same name, which is why they're both prefixed with W3C. So if anyone is a massive standards geek, you can just Google W3C trace context and W3C baggage, and you will find the actual specification that explains these in excruciating levels of detail. But for the moment, we now, through utilising the propagators, have all of our spans connecting together, which is what we want. Because one of the biggest problems I had as a front-end engineer was, is the problem front-end or is the problem one of the services it's connected to? I need to know where the bottleneck is. And then that's why the propagation is so important, because a UI is not an isolated component. It has connectivity to other things. And in order to figure out where the slowness is coming from, we need to see arguably not just the services it's connecting to, but potentially the underlying databases calls, the calls to Kafka, and it all needs to propagate and connect together. Now, the other bit that gets interesting and different with traces is that we can register numerous different instrumentations, and these basically outline the instrumentations. Things are quite well named in OpenTelemetry, but basically the types of data and attribute traces that we want to pull through. Web auto instrumentations is basically the default set. And the default set, there is technically 4, even though I've only put 2 in. That's because this is a demo and I want to show you how to do it on your own. So we've got fetch and HTTP request in here. I'm pretty sure you guess what these do. They pull in the HTTP requests. Pretty simple, straightforward. We've been talking about that. So that's the other piece that you need on top of the propagation to make sure you get this picture as before. We also have this notion of document load. What do we think document load does? It tells us the loading time of not just the document, i.e. the page of interest, but also the assets that are being loaded within it. So if you have, for example, a really heavy media page with tons and tons of images that are unoptimized, you'll be able to see a situation where you'll have a high document load and then your children underneath will be these massive, huge spans of resources that are taking ages. And that, therefore, as a result, is probably going to result in a largest contentful paint value for that page being basically in the floor. Or no, sorry, significantly high, because obviously you'd want it to be, it's going to be taking ages. One of the other things that gets added on in addition to the attributes is not just the time, but also knowing which asset it is, because if something's taking too long to load, you kind of want to know what it is so that you can go and fix it. And that's a quite important consideration for web. And as you can see, it's not just this notion of images, like I illustrated in my example. We've also got this idea of the style sheets and the other things. So if someone's not done proper minification on JavaScript files, you'll be able to see which file it is as well, which is quite useful. Or if you've added in other third-party dependent scripts. So Hotjar's quite a common one that basically adds a massive amount to your package. You can end up with a situation where you can actually see, oh, it's Hotjar that's actually taking so long to load, and therefore you make a decision about what you want to do with it. Now, the last one is user interaction instrumentation. Have we got any guesses about what this captures? It's a bit obvious, isn't it? It captures user interactions. Specifically, you need to set what event names you want, because you probably wouldn't want every interaction. That's probably going to get a bit unwieldy. But here you'll see that I've set up click and input. So the way that this looks is for a click, it's not very exciting. I can see how long the click event took to respond, which is useful in some regards. But and I can even see the particular element. So then I could start to do smart things. If I had counts on these, I could then start to see if a particular feature is being used based on the XPath expression saying, no one's using this particular feature because I can tell from this button that it's not being activated. And then we can look and try and understand why. Or we can actually, in the case of me, when I figured out nobody was using something, you can switch it off, which is one of the most satisfying things that we very rarely get to do. But also, when you correlate it with input, you can see that through the baggage construct as well, we're still able to correlate it with backend services. So this is an example of a simple text box known as an input, which is indeed going off to our server, written in Java, and getting the appropriate records that match that particular query and returning back. We're almost out of time, but we have talked about OTel, and client instrumentation for JavaScript. We've talked about the fact it's experimental, but we've also talked about with live coding, not live, with code examples, exactly how it can be done for capturing logs, metrics, and traces. If you're interested in giving it a go, the QR code is here with my code. It is commented. If you spot any issues, feel free to raise one. If you give it a try and it works for you, do let me know as well. And with that, we should have time for questions. Thank you very much.
Hello, thank you. Then I noticed that the code appears to be depending on using the browser detector. And I think, and it seems I'm not the only one thinking that this is running afoul of the e-privacy directives and which conditions the evolution of browsers. Is there a risk that it could become unavailable and break this kind of service?
So you're talking about the notion of the permissioning side of things.
Yeah, the need to only gather limited information, prevent the device fingerprinting, for
Yes.
example.
It does capture, it's capturing information such as the brand. So when you look at the browser attributes, it's things like brand, is it mobile, and things like that. But like any form of monitoring on a website, of course, we're all familiar with the pop-ups of consenting to giving our data. And obviously, what people should be doing is there should be a monitoring option at the bottom so you consent to monitoring, and in which case you would need to enable this. Obviously, if someone doesn't consent, you would probably need to disable it. And I get that's annoying because you're back to square one of this issue of I don't have the telemetry information to see what's going on. But that's how you do it in best practice, is basically utilize that option to allow people to opt in or out, and then you can capture the telemetry that way. Does that answer your question?
Oh, I'll do it there.
Sorry, would you mind passing?
Thanks. If you're exposing the OTel collector over the internet, what's stopping people just posting arbitrary metrics to it and causing cardinality explosion, killing it?
There's nothing. That's why you have a proxy.
Yeah.
In front of it, and that's actually considered best practice. So you have if I bring up the diagram again.
Is your example of Nginx controlling that at the moment, though, or is that something you'd need to configure yourself?
Something I'd need to configure because this is a toy.
Yeah.
It's running locally. I've not got the same concerns, but obviously you would have the same proxy whitelist, blacklist kind of configuration that would be considered best practice for any website. And you would need to make sure that the appropriate blocking is in place. You'd probably also want to consider, you could do it in the collector, but the proxy, you kind of need that step first. And that actually, when you look at the documentation, is considered the best practice to have the proxy and then the collector separate. And the collector can then do the basic processing, like dropping stuff. But no, you need the proxy in front to do what proxies do with regards to blocking and protection and firewall and all that other kind of stuff. You just can't get away without it.
Is that in a request path, or you need to inspect the body of the requests, the OTel requests?
So what I've done with mine, so I've not done it because it's obviously a toy. There are a couple of things you could do. I guess the origin source, like you could probably check against particular lists. I'm not a proxy expert, so I'm just surmising here. That's one thing you can do. There's also various services offered that do content blocking and stuff. Like I know we have that at Elastic for compliance to sanctions and all those other kind of things. So you'd want to make sure that your app's adhering to those generally. And that would all be applied separate. And actually that would apply to any form of traffic at all. So the other thing you'd need on the other side, if you think about it, because what you're describing is effectively like an overload attack to try and overload the system, is you'd probably want to have a SIM examining the volumes as well. And then if your volumes are starting to spike and you figure out that it's actually an attempted denial of service based on these spans, you would want to block and cut off the IP. So you'd need to leverage other practices on top. Does that make sense?
All right. Thank you so much.
Cool. Thank you, guys.